time-wise. So, hey, I thought we'd start off with this one. I put this one in the notes packet because I think it's a good way of tying in what we did last time with the little intro video stuff and now moving in towards definite integrals. But this is very much similar to what we did last Friday. So if you would, it says you get this nice definite integral there, integral from -3 to 1 of 5x dx. And this is asking us to write the Riemann sum, the thing with the sigma and the limit and all that stuff. Write the Riemann sum that would go with that, if that makes sense. So really similar to what we did last time, but just from a different angle. So please take a minute and give that one a shot. Use the magic words Riemann sum. And so that, for me, automatically means one thing. I'm going to start off with limit as n heads towards infinity of sigma from I equals 1 to n. To me, that's the easy part, right? Like every Riemann sum should look something like that. And then we try to get to the details. If you're going to be super duper general and really basic about the stuff that goes in the sigma, what would you say goes in there?
Base.
Yeah, say it. No, we're not talking about triangles.
I'm so sorry, I was looking at triangles and
Oh, got it. Yeah, we'll go there in just a second. You're right. It's base times height, right? Because we're talking about rectangle areas, which is base times height. So with this one, I guess I'll do it something like this. The base length would be what?
4 over n.
4 over n, yep. And of course, we're getting that from the fact that from here all the way over to there is 4, dividing it up into n subintervals. So 4 over n makes sense. And then how about the height? Any thoughts on that? Let me ask you this. What is the height based on? What about the function? The y value. Yeah, the output for the function. So would you guys agree with me that the y value is going to be 5 times input? And then, of course, doing the inputs, that's maybe the trickiest part of this. So what is the lowest possible input that could be there? -3. And then to move across the picture from left to right, I need to add something each time to get to the next rectangle. What do I need to add? 4 over n, yep. And then times I, the I allowing us to move from first rectangle to second rectangle to third, so on and so forth. And that would be a nice Riemann sum. Just to give you a little more flexibility, is there anybody that maybe, we talked about this a little bit last time. What if we did something like this?
Wow, you really did that?
Just asking what you think about that.
I don't.
You can see that it's exactly the same except in the way that I handled the input.
you are genius.
Well, frankly, I prefer this way too.
Wait, I'm confused.
He's going from right to left instead of left to right.
This would produce kind of a different result that we'd have to accommodate for, but I just wanted you to see the reasoning and see how we could still kind of use this to get to where we wanted to go. So just a thought there. So the last thing I was going to bring up was Meg's idea. This connects nicely with what we're going to talk about here in a little bit, and that is area. Meg, of course, recognized that, probably like all of you, these are two triangles because it's a linear function there. And so we really could have just used areas. If we were trying to get to an answer, we could have used areas to evaluate this definite integral. We could have used a Riemann sum, or we're going to find out later on today or tomorrow, we're going to find out or Wednesday, I guess, we could have used the fundamental theorem of calculus to get to the same place. So there'd be a number of ways for you to get there. Because it's a nice linear graph, area would have probably been the optimum way to do it because 1/2 BH and it's all over with, right? It's pretty quick and easy. Okay, hope that's a good tie-in to last time. I would like to talk a little bit more about area with you guys, and let's see if you guys can handle these 3 questions. Just a little note here. Sometimes f is continuous and lovely and everything, so we can do an integral of it, but There are going to be some parts of it where the outputs are negative. In that case, the definite integral will be negative, but we're never going to say that area is negative. Take that and see if you can run with that thought when we try to evaluate those three integrals on the right. And then if you want to think about the total area enclosed by f of x and x-axis, you're welcome to do that as well. So take a minute. Again, we're just going to work independently or with a friend, see if you can do these. You're asked to integrate from -4 to -1. That, of course, is talking about this interval from right here to right about there. And I think that there would be two ways for you to do this, one of which I think is correct yet very, very unwise, and I've seen it done before. The other one will be correct and very wise. I've also seen that before too. So the correct but unwise way would be to use some algebraic analysis and figure out the equation of that little line segment. You could do that, right?
Why would you do that?
And then you could also find the equation for this line segment. And then, maybe, gentlemen, you haven't seen how to do this yet. Then you'd find an antiderivative, which you've seen that. And then you'd apply this fundamental theorem part 1. But you'd have to do two of them, and you have to split it up into two parts. And all the veterans are like, no, thank you, for good reason, right? This is going to take you 10, 12, 15 minutes, and you hopefully would get it right. Whereas, here is a saying that I hope that you'll buy into. If you can't integrate, it rhymes. If you can't integrate, accumulate
Oh, that's way better than
area.
anything I was gonna
If you
say.
can't integrate, just accumulate.
I was like, multiply.
And so here, so listen up. Here, it's not true. If I were to say you simply can't integrate here, that's really not true, because you could find the equations for those line segments. You really could. So let's amend that a little bit and say if you can't integrate, or you'd rather not integrate, just accumulate, if that makes sense. So all I'm going to do here is recognize that instead of doing the formal, full-on fundamental theorem of calculus and doing antiderivatives and such, I can just accumulate the area, and that's going to get me what I want. I need to recognize that this part of the area does fall below the x-axis. This is what we were kind of talking about. And so remember, a definite integral is simply a summation of infinitely skinny things. So if you tell it to add up a bunch of negatives, guess what? The answer is going to be negative. If you tell it to add up a bunch of positives, that's what it's going to be. It's going to add up to be positive. So here, we would just find the area, and it's what, 1, 2, 3, so it's 3 by 4. So the area there is 6, but because we're accumulating a bunch of negatives, the integral would tell us the result is -6. Does that make sense? And we keep going then. -4 to 2, that's going to include the original plus this other little region. What did you guys notice about the blue region?
They're the same area. That's the same area as the
Just like the other one, except
positive.
above the x-axis. So here, if you wanted to show some steps, you would say this is -6 plus +6.
Not to brag it.
Fully canceling out, you'd get 0. So if I told you that the sum of the red area, listen now, if I told you that the sum of the red area and the sum of the blue area was 0, I would be completely wrong. It's not true at all. What's the sum of the red area and the blue area? 12. But if I said, what's the definite integral from -4 to 2, and said that that was 0, that would actually be true because I'm accumulating a bunch of negatives, and then I'm accumulating a bunch of positives, and then I'm adding the results, getting 0.
I'm positive that you're correct. Oh.
Thanks for not having negative energy, Nick. I appreciate that. Okay.
I feel attacked.
I couldn't think of a more clever way to say that. So then finally, you get to the integral from -4 to 4, and that does include that final little segment of the graph, which I'm highlighting in yellow. So here, we're accumulating from left to right. We're not messing around with equations of anything. I would say this is -6 plus +6 plus, what's the area of that yellow triangle? -4. Well, the area is 4, but the definite integral is going to spit out -4, right? Because of being below the x-axis. So plus -4, this obviously gives us a final value of -4 when we evaluate that, and we'd be done. So how about that last question? Find the total area enclosed by the graph of f and the x-axis. What would you guys say that is? 16, right? Basically a 6 and a 6 and a 4, you add them all up and you get 16. And that would be your final answer there. When you're talking about area can't be negative. If it could, wouldn't we go to the paint store and say, hey, this, the area, the outside of my house is negative 10,000 square feet. So you need to pay me a bunch of money for me to take some paint.
Just get antimatter paint and blow up half the planet.
Or that. I'd rather just have the money, though. That's just me. But you understand what I'm saying, right? Area is like area negative. I don't know if we can really deal with that, at least not in Calc 1 or 2 or whatever. So anyways, we'll leave it at that, I guess. That'd be cool, though. Any questions? Okay, so there are a couple of properties coming up of definite integrals. And really, honestly, I think most of it is just based on... Man, look at my colors. I just noticed. Those look cool.
I do it.
Red, yellow, blue. I think that looks sharp. Anyways.
Get a pastel colored.
You know what? I've got another app that you can make up your own colors.
We should switch over to that because I'm a fan.
But I can't do much recording with that.
All make our own coloring.
Maybe we could turn this math class into an art class.
Yes.
Sometimes it feels that way, which is nice. I just noticed that I started off with number 2 here. Please don't ask me why that is, because I don't have a clue. So let's start off with number 2, although really it's the first one.
Number 1 was right there.
Did I just count that as part of the example? I guess maybe I did. I suppose that's true. Okay, so knowing what you know about definite integrals and area, if we were doing the integral from a to a, in other words, the limits of integration matched, what would you guess the result would be? 0. Yeah, there's no room to... So 0 seems like a very reasonable answer, and I agree with you on that. So an example... Sorry, Meg?
I said, wasn't that a question last year? I think that was.
Oh, I guarantee there was at least one question where that came up. It probably wasn't asked so directly.
Yeah.
It was probably part of an FTC sort of a deal.
Yeah.
But yeah, almost for sure that had to have been there somewhere. So an example would be the integral from 4 to 4 of f of x. And this goes to Meg's point. I doubt I would ever just come right out and say, hey, what's the integral from 4 to 4 of something? That's just like sort of an insult to your intelligence. But this could show up in the course of a bigger process where you might say, I need to find this and I need to find that. And oh my gosh, integral from 4 to 4, that's just 0. And you move on, right? It makes it a lot easier, of course, if you can recognize that quickly. The next one, the integral from a to b of f is equal to the opposite of the integral from b to a. So for now, we're going to say if you switch the limits of integration, you switch the sign. So there's a lot deeper reasoning for this based on the fundamental theorem of calculus. And we'll get to that a little bit later, just based on the direction of subtraction. In other words, like 10 minus 7 and 7 minus 10 are opposites. And we'll get into that a little bit later. So an example here. Did you notice this, something curious about this definite integral, about the limits? Anything like unexpected or different? Yeah, it's like backwards, isn't it? Don't we normally accumulate from left to right?
Yes.
Yet this one is telling us to accumulate from right to left, from 5 to 2. So there's really nothing wrong with that necessarily. But if you wanted to get to a more comfortable notation that we're used to, integral from 2 to 5 of f of x dx, you're welcome to do that as long as you make the overall result the opposite sign of what it was before. And switch the limits around if you want for whatever reason. You can do that as long as you switch the sign around. How are we doing? Basically, does this make sense so far? Okay. So then the next one I think is really handy with area as far as proving why this works. If I've got the integral from a to b, and then I've got the integral from b to c. So in other words, you could think of it as this yellow area, and then I've got this green area. If I've got those two areas, what would be the total area? Yeah, just the integral from a to c. So if you have the integral from a to b, and then you got the integral from b to c, you could just do the whole thing, integral from a to c. And you can split it up or put it back together either way. You could start off with this and split it up into that, if you chose. I mean, sometimes that's going to be beneficial. Or you could start off with this, and you could condense it down to that. There we go. If that might be beneficial for you as well. Could go either way here. Either way is fine. So with that in mind, what would you think that the example could be simplified to be. Integral from 1 to 7. Yeah. Okay. Again, the goal here is that this makes sense. I think we got one or two more. Okay. So here we go. Numbers 5. Yeah, 5 and 6. This one is super useful. Both of these are super useful. We've already kind of done these with indefinite integrals, those antiderivatives. If you've got the definite integral of k times f of x dx, and k is some constant, what can you do with the k? You get it out. Now this is true of constant multiples, right? Not constant terms. So you're right, we can just bring this out. So it'd be k times the integral from a to b of f of x. We do whatever we got to do with the whole integral of f of x dx, and then you multiply the k back in. So in our little example there, what would be the k? 7. So if you wanted to, you could write 7 integral from negative 5 to 8 of f of x dx. I will do this often simply because if I want to look at my integrand and decide what do I need to do with my integrand to get this in the form that I want, getting that 7 out of there sometimes is the key for you to be able to see the pattern that you need to see, whereas when the 7 was in there, it's a little more confusing. You can only do this with a constant multiple. You cannot do this. Like if you had the integral from negative 5 to 8 of x times f of x dx, you cannot take the x out. This is constant multiple. Constant, not variable. If that makes sense. Okay, and then the last one. The last one is the definite integral of a sum or a difference. Can you guys describe what you could do here if you got the definite integral of... Split it up? Yeah, sure. Split it up into separate terms. That works. So I'd go integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. This is also a very, very handy thing to use. Sometimes we just do it real quick mentally. Other times, it's going to make all the difference as far as seeing if Timmy messed up, yes?
Oh, Timmy.
Sorry, I forgot about Timmy. Did Timmy mess up?
There's no Timmy anymore
Or did
in our
Timmy
class.
not?
That's so
I'm
sad.
sorry. I am sorry about that. We'll talk about who Timmy is here in a little bit. Not today, but
No,
the next couple
somebody
days.
should consider me legal Tim.
All right.
You'd be a great Tim.
I think I would.
You can pull it off.
Honestly, I prefer Timothy. So.
Timothy. Okay.
Yeah, Timmy for sure.
Okay. I
Makes
prefer
him sound a little more formal. Hey, so I would say
on a driver's license.
in this example, this is actually a prime opportunity to use the last couple of rules. I have seen people do what I'm about to do, and what I'm about to do is wrong, but it feels like it's the right thing to do. Check this out. See if you can identify what it is that I'm doing wrong.
That's lit. I'm gonna say that's awesome.
That is not
If you, I do have a question. Well, you're probably gonna explain it.
Now, I could still fix this. I definitely could fix this. However, as written, it's wrong, isn't it?
Yeah,
Yes.
totally.
Yes, sir.
What's wrong with it?
Well, you'd have to pull
X to
out
the fifth
first.
is not
Need to be x to the fifth.
Yeah, like I've all of a sudden made that x to the fifth 5x to the fifth, haven't I? So instead of doing something like that, what I could do is I could write integral from 3 to 4 of x to the fifth dx plus the integral from 3 to 4 of, oh, look at that, it's sine of x times 5. Now couldn't I pull the 5 out?
Yes, sir.
So then you'd end up with integral from 3 to 4 of x to the fifth dx plus 5 integral from 3 to 4 of sine of x. And doing it this way, of course, I have not over-applied the 5 to everything when it should only be applied to the second term. So little minor details like that can really be frustrating because you probably know exactly what you're doing, but because you didn't take the time to apply that little rule there, you might miss it and later on be like, oh, I totally should have had that. I would love for you to avoid making mistakes that you know better than. So anyways, just a thought there. Any questions? I think those are all the properties. I think there's maybe 1 or 2 examples here for us to work through. You good? Okay, so try the examples. It must be on the next page here. No, I didn't do examples?
Extra practice.
Fine, we'll just do them later. Okay, cool.
One up.
This works out good. So I've referenced this already. It was in the little intro video in a couple of parts. It's the fundamental theorem of calculus. And of course, you got to figure if it's the fundamental theorem of whatever. The word fundamental means that you got to know this stuff. This is definitely a key point in our class, and I would say this is key for both AB students and BC students. And I don't know how you got. I don't know where you stand with the whole intro video and some of the details here. I don't know specifically with those that might be rusty or are new folks where you are. Would you mind trying number 2 real quick? You can apply some properties. You can try to use fundamental theorem of calculus. The way our book puts it is this is fundamental theorem of calculus part 1, or we'll sometimes call it FTC 1. Other books, they just present it as the fundamental theorem of calculus with no parts. They just like give it to you, the whole thing, just in one shot. Other books, they change around what the 1 and the 2 are, and so there's no real importance to FTC 1 or 2 other than we just need to know that it's fundamental, and we need to know how to do it. Anyways. See how y'all do. Hey, will you try this one? You can do this. This will make it easier. Okay. Just do it.
What am I doing wrong?
It is recording you, so just be careful about any comments you might make about Santi or Justin.
Wait, please do that.
No, my God.
I was mixed up Logan with
Meg,
Santi, actually.
stop.
It wasn't you. It was
Wait, do it so he can see what
no,
I'm
it's
watching.
definitely-
Oh my gosh, is he gonna watch it?
So then here,
Oh,
my
yeah,
mind
just
says
for
fire,
eyes.
I go one direction. I have not called it. I have not called it.
I will do it.
face
Hold
yet.
on.
It'll probably happen. Sorry.
64.
Sorry for the PPE. All right, so Julia
That is not
is
what Julia put. What?
showing
Oh
us
yeah, it is. Okay, now
her
I get it.
solution to this one.
This is really nice pen.
Some pretty nice writing. I think she should be hired to write all the time instead of me. I struggle. Okay, so she's getting 14 for a final value. We can go over some of her steps up there. First of all, what do you
I
think
kinda
for the final
skipped some
result? Let's get that squared away. Do you think 14
Yes.
is the right answer? Meg says yes.
That's what I got.
I say no.
You say no. Well, let's go through it step by step.
It's not that. You
what
that's what you
is-
can do.
Oh,
What is
not row.
2x to the 3 halves?
I
What is that
see.
supposed to be?
A square root of x.
Yeah, that's your antiderivative, right?
I
Oh, that's what
I
you meant.
know what I revoked what I said. I don't think it's right.
You don't think it's right? Okay, okay.
I just thought I'd come back
Dang.
and establish
Really
that.
take backsies.
So let's see here. You
Uh-oh.
guys,
14.
let's just let's troubleshoot this. If you think it's wrong, do you guys think that 2x to the 3 halves is the right antiderivative or the wrong antiderivative?
Right.
Yes.
It's right. Okay.
Gosh, why did I forget?
I think that I would agree with you for sure. She handled the 3. Maybe hopefully you handled the constant multiple of 3 there. Got 2x
Got
to 3
it.
halves. She's evaluating from 1 to 4. So Aiden,
Someone's gonna
Jack,
be so
Forrest, you guys
disappointed.
okay with that vertical line meaning evaluated from 1 to 4? Means you've done the antiderivative, now we're going to evaluate it. Is that okay?
What is this?
Yes, sir.
Okay.
Oh,
And
it's
then, let's
fun.
see here, she plugged in a 4. She got 4 to the 3 halves. Let's see here, 4 to the 3 halves would be 8. And 8 times 2 would be
16.
16. 1 to the 3 halves, she plugged in the lower, the second number there. 1 to the 3 halves would be 1. 2 times 1 is
Dude, nice
12.
2.
I'm sorry.
So where are we at? I mean, it
We
seems
need to
like
move-
nobody's disagreeing with any of these parts yet, but we disagree. Are we coming around? Maybe Julia was right or wrong? What do you think, Aiden?
No.
You accept the value for b and a, it should be 2 minus 16 instead of 16 minus 2.
Oh, gotcha. So you're thinking the answer should be negative 14. Gotcha.
I think it's
The rest of you that
42.
object, what do you think?
I think it's 42.
What?
You think it's 42?
Wait, no, hold up.
I have a question.
Oh wait, shoot, no, never mind.
Do you need to
I
multiply by
retract my
Wait.
statement.
You retract your statement,
Yes.
okay?
I would
Meg?
like to review my statement.
Do you? I have a clarifying question, and then I'm going to stay where I came down.
Yes, let's hear it, let's hear it.
Do you need to multiply by 3 back?
She already did.
Well, the 3 certainly
That's what I
cannot
did.
disappear. And Julie might be able to explain where it went.
Okay, because like when
You
you
can
do
show
that,
what you show.
Okay.
Show, like, maybe that
so
step
if you
showed.
took it out, it would be 3 antiderivative of x to the 1/2, which would be 3 times 2/3 x to the 3/2. And they cancel and you get 2x to the 3/2.
Yeah, I totally see. Okay, I'm on Julia's side now. I come back to my tangent full
Yep,
circle.
she's right.
She's right.
I told you that she was right at the beginning.
And then you doubted me.
No, I never stopped doubting
Hey,
you. I tested
I think 14 is the right answer. Like, I had to stop and think, did Julia mess up in arithmetic? And we all do sometimes, right?
Yeah.
I
No,
don't,
I did.
I don't think she made any mistake. Did she explain the 3 well enough?
Yeah.
I
Is
just
the
kind of
three
did it in my
really
head at
linear? She
first.
didn't really show that step, but
No.
everything was not wrong. I think it's a pretty good presentation. She got all the elements there. She got the antiderivative. She showed fundamental theorem of calculus. She got the answer. I think all those elements are there. I think it looks great.
You did a great job.
Yeah, okay, cool.
Thank you.
Well done.
Thank
Other thoughts, questions? Let's try another one here. This is good. Rust can come off. You can become shinier again. You don't have to be rusty. Are you okay with the ordering?
Yeah.
We're
I
always
thought it
gonna-
was that was f of a minus f of b. I
It's
just
f of b
didn't
minus
read
f of
it.
a. Okay, there we go. There we go. Little things to pick up on. Yep. And by the way, to Aiden's point, when you're doing a definite integral and you think about the ordering of things, it's not you don't go evaluation at numerically higher minus evaluation at numerically lower. You go evaluation at the physically higher minus the evaluation at physically lower. And so this is where we get into that whole, do we want to accumulate from right to left or left to right?
Oh, that's why that.
Does that make sense?
Yeah.
So we typically have it where like the physically lower number is also numerically lower. That's how we typically do it. But if they happen to be switched around, you can just proceed normally, or you can switch them how you want them and then just change the result, the sign of the result. Does that make sense? So you have some options there, how you navigate through that. That's up to you. Okay, please try number 3. If you haven't already looked at it, it's a lovely question. And you should definitely try it. And if you did get done with number 3, you certainly could move on and try number 4 as well.
Tangent is derivative of secant squared.
Tangent's derivative is
Oh, yeah,
secant
yeah,
squared.
yeah. So it would just be.
Oh, you've discovered an important thing.
What do I do now?
With what? Use your old friend, the unit circle. I don't know how to help you there other than we need to work on it, but yeah, you've gotten to a good place. Don't stop now. Tangent of pi over 2 doesn't exist. I agree with you there. Remember, tangent is y over x on the unit circle?
It's just 0 over 1, right? It's y over, so that'd be
Y over x, and so we're talking about over here.
0, yeah, I think that
Oh,
would
so it would just be 0.
be, yeah,
So
Yeah.
it would be tangent of pi over 4.
which is just 1, right?
So it would just be 1 minus 0. I
Hey,
feel
now we're
very dumb.
talking.
Do you ever just feel really stupid about yours?
Let's go.
Let's stop making judgmental thoughts about ourselves. Seriously, like we're all in progress. We're all like pretty good at certain things or not so good at certain things. It's about progress,
I'm
right?
really good at making judgmental thoughts about myself.
No, please don't. Please don't. You're going to start getting upset about the person making fun of you. And it's you making fun of you. Hey, Forrest, do you know what the antiderivative of secant squared is? Tangent, yeah. And isn't that based on your derivative skills?
I don't know.
So I would say, so guys, hey, listen up, please. Here's what I'm hoping you're thinking here. You might at first look at this and say, oh my gosh, antiderivative of secant squared, what on earth? And then hopefully in the process of you thinking that, you'd say, I've seen that somewhere before, right? Oh yeah, isn't secant squared just the derivative of tangent? So the antiderivative of secant squared would then have to be tangent, right? So it's based on understanding the derivative skills and reversing those. This would then be evaluated from 0 to pi over 4. Hey, folks that were, maybe disappointed in your test scores from last time, let me give you some hints about things that I'm going to look for. I'm going to want to see that step. I'm going to want to see that you found the antiderivative. And then I'm going to want to see that you have used fundamental theorem of calculus by plugging in the physically higher number minus the physically lower number. And then this is really similar stepwise to what Julia had before. You just evaluate this, and this is where Peyton's favorite thing, the unit circle, becomes a thing. Tangent of pi over 4, of course, is 1. Tangent of 0 is 0. So you'd end up with a final value of 1 for this one. Anyways, Meg, your thought?
If you didn't use sub, would you still get tan?
If you didn't use what?
If you did use sub, would you still get tan?
Oh, U substitution?
Yeah.
No, I don't think so, because would you make your U secant?
Yeah.
And then the problem is for U substitution work, the other factor has to be the derivative of that.
Yeah.
So the other factor would have to be secant tangent. And you'd be like, I'm stuck, right?
Yeah. Okay.
That's okay.
You'll get them next time.
I think really this one is really based on knowing the derivative of tangent of secant squared.
Yeah.
Yikes. Oh boy, this would be...
Sorry.
I'm just trying to think of a way to do this without knowing that. And...
I'm a failure.
Well, hey, you want to know? Hey, veterans, this is probably worth saying right now. You know this, and I think everybody's starting to get a sense of this. The nature of the integrand can dramatically up the difficulty very easily.
Oh, yeah.
For example, if you have antiderivative of secant squared x dx, assuming that you remember the whole derivative of tangent is that sort of thing, not terribly difficult, right? Now, I just make one minor change and I make it x times secant squared of x. Way more difficult. Not some minor little, we'll be fine. This would radically change our strategy. We'll actually look at how to deal with this stuff this year. It's actually not that hard, but it would be a completely different strategy than what you've done before. Another example, veterans, did you know that up to this point, unless you looked it up, you don't have any idea how to do this?
I don't.
You know how to do this.
I do.
What's that? Yeah, this is ln of absolute value of x plus c. But you don't have any idea how to do that yet. This year you'll learn how to do that. So that's what I'm saying. Like little minor changes or like unexpected changes to an integrand can have really significant impacts on how you approach a question. So we want to take great care to pay attention to that. Okay, let's try number 4. The integral from 0 to 9. Now this one is probably of the 3 we've done so far. Number 4 is going to be the toughest one. It's going to require some rewriting. So please take a minute and do some rewriting. I'll get scrolled to the right spot here. Aiden, your question?
Is this fine to write capital F of x equals tangent x, or do I have to do just with
So, great question. So I would say the way that you have presented that is good. Like you have defined what capital F means, and then you've used that accordingly. I'll put it like this. First of all, I see nothing wrong with what you've done here. I think it's great. I don't see a compelling reason to do it that way, but I don't think it's going to take any more or less ink either way. Right? What you've done here is, I think that's great notation. Same thing here. I think that's all great notation. You're not going to see me do that all that often because my capital F's end up looking like lowercase f's, and I can get confused really easily for that reason. But I think your notation, your communication is very strong there. That's good. Oh, sorry.
Okay.
Hey, check out solution up there.
I didn't even take the antiderivative. I just multiplied it out.
Who, me?
Do you ever just do that to yourself? You just don't even take the antiderivative. It's like, what do you do?
Okay, I brought
X times x to the negative 1/2.
That's what I got.
So you got x to the
Oh,
one
it's
half.
negative 1/2. Oh my
Honestly,
god.
It's okay. Can't win
No,
them
it's
all.
not.
You
This
can't
is,
win them all.
I'm gonna fight.
Is this an eraser? I think this is an eraser.
If you want to erase, you can just click on the eraser. And
I don't know
then-
which one that is. Oh, it's this one.
That one right there.
This one?
Yep, the little rectangle.
Oh,
Yep.
there she is.
And then also, if you just don't like what you wrote and you want to reverse it, you can hit the reverse button and it'll just
Oh, okay.
reverse. It'll just take off what you just wrote.
Over one half would be like times.
Okay, that's what I was.
Nick, if you wouldn't mind saying, "Oh my gosh," instead of the thing you just said. Sorry, might seem like a minor thing, but
No, I understand.
I'm sure you'd be insulted if I'm like, "Man, that was one nick of a mistake you just made."
Yeah, no.
Holy Nick. Right? You'd be like, "Hey, I'm not really okay with you using my name.
Wait, I've actually never thought about it like that.
What in the name of Nick is wrong with you?" And like,
Yeah.
just like,
Can we start
essentially-
using that?
No, I don't want you to. I'm using that as an example of something he would probably not prefer.
Yeah.
So, yeah. I would never say that.
No.
Other than for illustrative purposes.
I would.
So with this one, I like that you did a little. So, you flip it rounded up, which I think is the right one. But you flipping the number to the top is not an antiderivative. So I don't like this being there. You should still be, like at this point, you have done any antiderivative. No, you manipulated it, there's no
The last year, like, we it's like
No, I don't think so. This means evaluating from 0 to 9. This means that you need to do an antiderivative, and I would say at this point you have not done an antiderivative yet. So what you need to do, if you see Jack kind of illustrated this up here, you don't want to have a product.
Wait,
You want to distribute this.
I got a 42 as my answer.
Distribute this, and then once
Hold
you've
on,
done that,
can-
then you can do your antiderivative, and then this is going to turn into the
2x to the
vertical
1
line
half.
from 0 to 9. After you've done your antiderivative.
This year.
Does that make sense?
Yeah.
Okay. We'll see what Jack did
Wait,
here.
you get this 4x over 3 halves minus 2x to 1 half.
Oh God. Well, you know what? We'll figure out what's wrong.
Through the second step.
Okay.
Don't you bring that negative 1 half?
We can discuss. We can certainly discuss. So Jack, so while he's finishing up, I don't know how far you guys have gotten on this. You can see that in his second step he's simplified. Are you okay with the simplification there? The 2x to the 1 half plus x to the negative 1 half? I think that certainly makes sense. How about his antiderivative?
That's where I am confused. That's where there'd be over.
So 4
So you bring the new one down.
Now you bring the
So
new
you
one.
add and then bring down instead of bring down and then add.
Yeah.
Got it,
Bring down.
totally.
Add then bring down.
Yeah,
How cute.
man.
And then flippity flop.
Yeah, at least mine
Flippity
isn't a
floppity.
substitute for mistake.
Okay.
Okay. So
We're
I
gonna-
think you guys were objecting a little bit to Jack's answer, I thought. What?
I got 42.
You got 42?
I got 40.
Rude.
48.
48. What planet do you
Oh,
live
look
on?
at there.
Rude.
I got 30.
What planet do you live on?
Alright, clearly something has gone horribly wrong.
Judgment is flying all over the place.
all that I got.
Oh my
Hey
gosh.
guys, hey, let's focus and finish well. So do you guys agree with Jack's antiderivative of 4/3 x to 3 halves plus 2x to 1 half?
Yes.
So if we all agree up to that point, that's good news. I think that's right. He evaluated from 0 to 9, so he plugged in a 9. 9 to the 3 halves,
It's 27.
27. 27. 27 times 4/3, I think, is 36, is it not?
Yes.
It sure is.
So I think that thing with the 721 should probably just be a 36. I don't know where you got the 721 from.
Hold on. 810. Wait. Let me figure this out.
9 to the
A1 times
9
9.
to the third.
729.
729, there we go.
Which still doesn't make sense.
Square root of 729 is just 27.
Right.
Over
Dang.
3 is 9
Because
times
he's done,
4.
I did-
He's done the square root
That
of
is
9
so good.
first
How do you
thing.
know that?
That's what
Dude,
I
I
like to
just
do.
have
like
them
to
all
go small and big
memorized.
instead of bigger than small.
Like it's just like
Question?
all
I got
over there.
4x to the 1 half instead of 2x to the 1 half.
Ah, okay. So I think the issue is this 2 only applies to the first term. So it's there. I think you mistakenly applied it to the second term as well.
Good.
Oh,
Does that make sense? Like
Yeah,
that
yeah.
2 is only on the first one.
yeah, I don't know how I did that.
Okay, so then, so you guys okay with 42? I think 42
Yes.
is the right answer.
I'm great with that, mostly because I got it.
I did my subtraction wrong. That's why I got the 1. This is 21, 7,
It's-
7,
See, 'cause
29.
like
So let's see here.
36
So you've
plus
got
6 is 42.
Times 27 is just
It's
108.
because, you know, math and stuff.
136 over 3, sure, 42. Hey, so, yeah, Jack's got the right answer up there. Isn't that the strangest version of 42 you've ever seen?
Yeah.
But it's 42, so it's lovely. It's absolutely lovely. Hey, I want to just plant one thought in your head here before we go, and this will lead us nicely into tomorrow. We're definitely not going to do this whole thing here, but I did want to ask you a question about this. We want to do the integral from 0 to 2 of g of x, and g of x is piecewise, right? Did you notice, as you read over this, do you notice that joining point, is inside the interval from 0 to 2? So in other words, partway through the interval, the rule for the function is going to change. Any thoughts on what we could do? What do you think, Julia?
0 to 1/2 and then 1/2 to 2.
Yes.
Wow.
We could do this. And then I would add to that the integral from 1/2 to 2. I wanted to make sure we got this in here today because isn't this one of our properties? It's one of those scenarios where taking a definite integral and splitting it into 2 makes a lot of sense. Whereas sometimes taking 2 of them and combining them into 1, sometimes that makes sense. In this case, we want to split it up because then we can apply the particular rule for g of x that goes with the domain that it actually goes with. And then we'll deal with the mechanics of it. We'll deal with that tomorrow. But anyways, that's it. You're remembering. You're coming around. We're getting there. What do you think, Aiden? You're still thinking about this one.
Because would it be an open-ended integral outside of one of the integrals?
An open-ended what?
Because it's
You guys
less-
are good to go.
Because it's x is less than 1/2 of the first part of it. So would that do it on the integral?
Well, so in order to be a function, you can't have a double closed.
3 points.
And then you make
Best interception I've ever seen.
Right, so one of them's open. If you're wondering, like, wouldn't that leave something off?
Yeah.
Okay, so it would be, from the left, we'd be approaching an open circle, right, from the 0 side. Like, how close could you get to 1/2?
Yeah, so then they called me. They're like, yeah, you actually can fill it out. Like I'm already in the school district.
So whether that's an open or a closed part of the interval, it actually doesn't matter because how close could you get to 1/2? Aren't we doing a limit as n goes towards infinity anyways, right? We're just getting closer and closer and closer, and you might get really close, but then I can get closer. And then you could get even closer to me, and we could do this forever. All we're really looking for, we just want to recognize that a definite integral is a limit as it goes to infinity of a solution. We can even add up an infinite number of things anyways. Thank you, have a good day. So the fact that we are trying to get super duper close to something, that kind of by definition is what we're doing anyways.
Yeah.
So it's a good question. It's a very good question.